Hello, good morning viewers. In this tutorial, we are going to find the derivative of these three inverse trig functions. In one of our previous lessons, we have seen how to differentiate inverse trig functions step by step. But in this tutorial, I'm going to apply the formulas deriving. Let's start with the first one. The first one is y equal to cos inverse of 9x minus 1. We are going to let 9x minus 1 to be equal to u. So u equal to 9x minus 1. U prime, which is the derivative of u with respect to x, will be equal to just 9. Because the derivative of 9x is 9, derivative of negative 1 is 0. So our equation can now be written as y equal to inverse cos of u. So which formula are we going to apply? We are going to apply this formula right here. Negative u prime divided by the square root of 1 minus u squared. That is going to be our answer. So let's substitute. Dy over dx will now be equal to negative u prime, and our u prime is 9. So we have negative 9. Divided by the square root of 1 minus u squared, and our u is 9x minus 1. So we have 9x minus 1 all squared. And this is the derivative of inverse cos of 9x minus 1. Let us move to the second one, which is y equal to inverse tangent of 3 minus 2x. I have written the question already. We are going to let u to be equal to 3 minus 2x. We differentiate that. U prime is equal to derivative of 3, which is constant, is 0. Derivative of negative 2x is negative 2. Y will now be equal to inverse tangent of u, because we have let that to be equal to u. Which formula are we going to use now? We are going to use this formula right here. That is u prime divided by 1 plus u squared if you have inverse tangent. So dy over dx will be equal to u prime divided by 1 plus u squared. Let us substitute everything here. This becomes, our u prime is negative 2. So we have negative 2 divided by 1 plus our u squared. U is 3 minus 2x. 3 minus 2x all squared. If you like, you can expand the parentheses, but I will leave it like this. Now let us move to the last one. I've already written the question here. Y is equal to inverse cotangent of 2 cos x. So let u be equal to this times 2 cos x. 2 is constant here, so we are going to differentiate cos x. U prime is equal to our constant 2, but the derivative of cos x is negative sine x. So we are going to apply negative sign here. Therefore, y is now equal to inverse cotangent of u. Which formula are we going to apply? The only difference between the previous one is the negative sign. You can see for inverse cotangent, it has a negative sign, and for inverse tangent, it doesn't. That is just the difference between the two of them. So dy over dx will be equal to negative u prime divided by 1 plus u squared. Dy over dx, we are going to substitute. Our u prime is negative 2 sine x, but because of this negative, it is going to become positive. So we have 2 sine x to the top, and to the bottom we have 1 plus u squared. Remember, our u is 2 cos x. So we have 2 cos x all squared. We can expand this if we like. It is going to become 2 sine x divided by 1 plus 4 cos squared x. And this is just the derivative of this inverse cotangent of 2 cos x. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. In case when you have inverse secant, you can use this formula, which is u prime divided by absolute value of u multiplied by the square root of u squared minus 1. For inverse cosecant, you're going to apply this formula right here. We have negative u prime divided by the absolute value of u multiplied by the square root of u squared minus 1. Thank you and stay blessed.